Optical path means what? Optical path. Optical path means the distance traveled by a light in vacuum. At the same time, it travels in the medium. At the same time,
Yes,
it will travels in the medium, that distance, which is called it as a optical path. Now, if I call the d is the distance, so d is the distance in a medium. Now tell me now here, the time taken by the medium to travel the d distance is how much now? Time t is equal to what we can say now, d by v.
yes, sir.
And what the v is the velocity in a
Sir,
medium.
velocity.
Velocity we can write as what, tell me now, that is given as c by mu now.
Yes, sir.
So it will come to be a what element of mu d into c.
Yes, sir.
So time taken by the light to travel inside the medium. Inside the medium. So here this is some medium. So this distance, which is a d. Refractive index is mu. The light ray will take a, so traveling from here to here will take a time of t will take. This much time will take. The same light ray now I'm allowing to pass through the air. Now this
Yes,
is
sir.
a medium. Now I'm allowing the same light ray will pass through the air now here. Now this is a air. How much distance will travel we need to find out now here. Now the distance
Yes,
we are calling distance in air. I'm calling it as d air. Distance is equal to what, tell me now? Velocity into time now.
yes, sir.
Speed in air is c and same time of t. That should be equal to c into t value we got now, that is equal to mu d by c. C will get cancelled. The distance in air, which will be equal to how much now, mu d. This is called it as a optical path. This is called as a optical path. Okay.
Okay, sir.
Optical path is given by simply mu into d. Right? Next one.
Yes, sir.
Optical path is always greater than the actual path. Optical path is always greater than the actual path length. Okay. Now,
Okay, sir.
so if they given the situation now, in time t, light travels a distance of d1 in a medium of refractive index mu1, d2 in a medium of refractive index mu2. In that cases, which is given as mu1 d1 equal to mu2 d2.
Yes, sir.
Mu1 d1 is equal to mu2 d2. Next, the difference between the two distances is called as optical path difference. Optical path difference. Optical path difference will denote as a delta x. Delta x, which is given as actual distance is d. Optical distance is a mu d. Mu d optical distance minus actual distance. That is given as mu minus 1 into d. This is called as optical path difference.
Yes, sir.
And here we assuming this as the light rays are placed in the same medium. If they are placed at two different medium, if they place, in those cases, optical path difference, which will come to be a delta x, which will be written as what, tell me now? It is a medium of refractive index mu1. light. So this is which is given as mu2 by mu1 minus 1 into d. And so what they're saying here now, this is the light is traveling through this medium. This medium refractive index is mu2. The surrounding medium refractive index is mu1. In this case, delta x is equal to what? Tell me now. Mu2 by mu1 minus 1 into d. D is the actual distance. This distance is d. Okay?
Yes, sir. 1 minute.
Hmm.
Sir, this last 2 points, can I explain again, sir? The optical path difference and this last point.
Optical path difference means the difference between the actual distance and this one optical path difference distance. What is the optical distance is a which is a mu d. Actual distance is what tell me now d na. The difference between these two is called as a path difference.
Yes, sir.
Path difference means a difference between the two distances. What is a path now? One is a optical distance, the other one is a actual distance.
Yes, sir.
Okay.
Okay, sir. So this last point also can
Last point means what? Tell me now here. Earlier, so the light is moving in a medium, air it is moving.
Yes, sir.
Here, this medium is what? Tell me we have taken this air instead of air. So let us consider this also one medium having refractive index is something we have, that is mu2 is there, mu1 is there. Then what I need to do here, then mu2 by mu1 minus 1 will come. Then we should take the relative refractive index we should take.
Yes, sir.
Okay, if we are doing an
Okay, sir.
experiment in some other medium, then we should do the relative refractive index.
Yes, sir.
Okay,
Okay, sir.
next, yeah, take this problem. Consider slabs of media A, B, and C arranged as shown in figure. Okay. The refractive index of A is 1.5, C is 1.4. If the number of waves in A equal to number of waves in the combination of B and C, then they ask them to find a refractive index, they ask them to find. Okay.
Yes, sir.
Now, first of all, so this is wave means what? Tell me now. So here we should consider wave means sinusoidal signal like this. Now here, right. So this is called as one wave. Okay. This is
Yes,
called
sir.
as one wave. Now let us say we have one more is there like this. Then how many waves are here? How many waves
Sir,
are there? Here, how many waves are there?
two, sir. Like,
Yes, now here in this case, from here to here, this is called as one wave, and this
yes, sir.
is one wave, like this we have. So from
Yes, sir.
here to here, this distance is called as a lambda wavelength,
Yes, sir.
and this is called as a one more lambda. Okay. So
Okay,
here
sir.
the total wavelength from here to here is how much, you tell me now? 2 lambda na?
Yes, sir.
So 2 lambda means that's why we have a two waves are there here. In this we have a two waves. Understood?
Yes, sir. Understood.
So from this what we can write now, simply the number of waves. Number of waves means what, tell me now? Which is equal to total distance, the distance by distance from here to here. If we call the distance is something d, that is the distance by wavelength lambda. Okay, this is
Okay,
the
sir.
number of waves. Fine. Now you can see now here. So let's find the number of waves in A. If I say number of waves in A, which is given as A length is how much? This complete length now from here to here, we need to see this length. So this
Yes, sir.
length is how much?
Sir, 3x.
Yeah, so
A
this
length.
length is okay. So 3x by wavelength of A.
Yes, sir.
Okay. Now, so this is, now similarly, we can find the number of waves in B. How many?
Sir, in B, like x by lambda.
Yes, so x
Yes, sir.
by
X by
wavelength
lambda
of
B.
B. So lambda B.
Yes, sir.
Okay. Now, similarly, we can write the number of waves in C. How much
Yes, sir.
now? This is 2x by what now here? Lambda C. Okay.
Lambda C.
Now see what
Yes,
they
sir.
are saying now. What they are saying now in the equation, in the problem, what they given. And we'll write one more thing here. Lambda A. Lambda wavelength in any medium is given by what? Tell me now. Wavelength in air by refractive index of the medium.
Yes, sir.
Okay. So similarly, we can say this lambda B, which is given as what? Lambda naught by mu B. Next,
Yes, sir.
lambda C is equal to what? Tell me now. Lambda
Lambda not
naught
by
by
mu B. Mu
mu
C.
C. Okay. If I
Okay, sir.
place this thing, we can get this NA value how much now? So mu A will go to numerator. So 3x
Sir,
mu.
so like here, like which formula is this one? So like lambda equal to lambda not by mu A.
So yesterday we have seen na. So velocity in a medium. Velocity in a medium is what? Tell me. Velocity in a medium, which is equal to C by mu.
Yes, sir.
Similarly, wavelength in a medium, and which will be equal to what? Tell me now. Wavelength in air by mu.
Okay, okay. Yes, sir. Yes, sir.
Now tell me now. Similarly, NB now here
Sir,
what?
so like another formula also we seen, so like V equal to 3 into 10 power 8 by under root nu naught into epsilon naught.
C means 3 into 10 power 8 only na.
Yes, like in denominator also like under root nu naught and epsilon naught. That is
That
the same
that
formula. Yes.
so that mu naught epsilon r is nothing but mu. This
Okay,
is
okay, yes, sir.
nothing but square root of this is mu r epsilon r.
Yes, sir, yes, sir. Understood, sir.
That is a refractive index. Now
Yes,
tell
sir.
me NB now. What is this NB now here? We can play lambda b in this equation now.
Yes, sir.
So we'll come it as x into mu b by lambda naught.
Yes, sir.
Next NC, tell me. So this
Sir,
is 2x
mu naught
mu c by lambda naught. Now see the statement what they given. See the statement now what they given.
Yes, sir. If number of waves in A equal to combination of B and C given.
That means what we can write now here, the number of waves
NA
in,
equal to NB plus NB6.
yes, so that is NA which is equal to what we can write now, NB plus NC na.
Yes, sir.
So we can place the NA and NB value here.
Yes, sir.
How much is NA value?
Sir, 3x mu A by lambda naught.
Yes, so that is 3x mu A by lambda naught, which is equal to NB means x mu B
X
by
mu B by
lambda naught plus
2x
2x
mu C by lambda naught.
mu C by lambda naught. Simplify it.
Yes, sir.
Now simplify it now here. Lambda naught will get cancelled, x value will get cancelled. So that means 3 mu A and which is equal to what, tell me now, this is mu B plus 2 mu C. And so here we need to get what, tell me now? Refractive index of B we need to get. A value given, yes, 1.5 and C is 1.4. We can substitute now.
Yes, sir.
A is 1.5 and so B value we need to get plus C value 1.4. Yeah, simplify, get the mu B value.
Yes, sir.
So this value 4.5 minus this is 2.8, which will be equal to mu B. So how much is mu B value?
Yes, sir. 1 minute. 1.7. 1.7.
1.7. Right.
Yes, sir.
Next. And take the next one. Take this one here. The light is traveling from 1 to 4. The refractive indices they given. The angle of incidence is theta, which the beam just misses. So entering the region 4 is this much. Then they ask him to find the value of x. They ask him to find. Fine. So what we need to do here, we just need to apply the Snell's laws.
Yes, sir.
Apply the Snell's law. Here we have just to directly we can do here first medium to fourth medium we can apply simply. Okay. Here this medium, yes, refractive index, this is n naught. Okay, so tell me now here. So first medium and this medium we can apply. No need to see the intermediate mediums. Okay, this medium refractive index is how much now? Which is a n naught. And angle is how much now? This is sine theta. And which is equal to what? Tell me now. And this medium refractive index is how much?
Sir, n naught. No, sir.
So this last medium only we need to see directly. So n naught by 8.
Okay. N naught by 8.
N naught by 8. And so this what they're saying here, they're saying this as a no, the just misses entering the region. So that means it is not entering into this medium. So that means the light ray which is going here, after that what happens now, it is not going to that medium, it is going like this only.
Yes, sir.
So that means what happens, you can see now in this case, if it is like that, then we'll call this as what, tell me now. So here then the light ray just lies on the surface only now.
Yes, sir.
Will lies now, that means what, the angle of refraction now, 90 degrees. Angle of refraction means how much now? 90 degrees. Did you remember this thing, critical angle formula then, first of all? Critical angle. So that means light ray which is not going to this medium. That means what happens now? It should be a critical angle. Angle of incidence is a critical angle. It does not enter
Yes,
into
sir.
other medium. The critical
Yes, sir.
angle theta c, if I say, which will be equal to sine inverse of, we can say now here, mu r by mu d. What the
Yes,
mu
sir.
r means, what, tell me now? The refractive index of rarer medium. Mu d means refractive index of denser medium. Here, this is the medium here, this is the other medium. And so here always small value numerator, big value denominator, keep in mind.
Sir.
Small value in the numerator, refractive index, which is small value
Yes, sir.
numerator, big value in the denominator, always simply.
Yes, sir.
So how much the critical angle here? That is sine inverse of, what you tell me now here? In this mirror, refractive index is n naught. In this mirror, refractive index is how much?
Sir, N naught by 8, sir.
Which is the smaller value? Which is the smaller value in these two?
N naught smaller values.
Here we have n naught. Here this is how much? Yeah.
N naught by 8. Okay, N
Which
naught
is
by 8 is the
smaller
smaller value.
value?
N naught by 8.
That is the numerator. N naught by
Okay.
8 by, that is n naught.
Yes, sir.
So that means how much the theta c will come to be a? That is sine inverse of 1 by 8. Okay. Then that's
Okay.
why this x value equal to how much now? 8. So the light is not entering into fourth medium. Not entering into fourth medium. That means what happens to the light? What happened to light now? Light is get reflected now.
Yes, sir.
That
Reflected.
means the light ray will experience a TIR.
Sir?
TIR, total internal reflection.
Yes, sir.
Hmm. Right.
Yes, sir.
If the light ray does not enter into the medium, that means the light ray has to suffer a total internal reflection. It is not going to that medium, it is going back to the initial medium only.
Yes, sir.
Isn't it?
Yes, sir. Yes, sir.
Next one.
Sir.
Ah,
Yes, sir. Nothing.
Next one, apparent depth.
Yes, sir.
Apparent depth. So if I call this as a dr, I'm calling it as real depth. Real depth means real distance.
Yes, sir.
Real depth. And dA, I'm calling it as a apparent depth, apparent distance.
Yes, sir.
And the relation between them, which will be equal to apparent depth, which is equal to, so this is the refractive index of observer medium. refractive index of observer medium by, so real depth, actual distance by refractive index of object medium. Okay.
Okay.
Apparent depth is what? Tell me now here. So first we should multiply with the refractive index of observer. OBS means observer medium and OBJ means object medium. Okay.
Yes, sir.
So remember this thing here. Refractive index of, so this is first we'll write it as what? Tell me now. Observer into dr by refractive index of object,
Yes, sir.
right?
Yes, sir. 1 minute.
Hmm. So this is mu obs means what? Tell me. A refractive index of observer medium. Observer medium, and that is mu obj means refractive index of object medium. So where you can see this type of action, you can see this thing, and let us say here in a, let us say we have taken a tub. A tub, you have placed one object.
Yes, sir.
Tub, you have taken a water, you have taken, and there is some object is there. When you are seeing from the top of the, this is the tub, the object will appears to be some other location.
Yes, sir.
So let us say coin is there inside the water. So you can observe here the coin is not, it appears some other location. It is not exactly at the location, isn't it? If you observe, that
Yes,
is
sir. Yes, sir.
because of the apparent depth.
Yes, sir.
Okay, it will appear at some other locations, isn't it?
Yes, yes, sir.
Hmm. Now take this problem. Two immiscible liquids of refractive indices given 8 by 5, 3 by 2 respectively are put in a beaker as shown in the figure. Okay, the height of each column is 6 centimeters. A coin is placed at the bottom of the beaker. Okay, for the near normal vision, the apparent depth of the coin is, now. So here is a coin is there. Another person. Here is observer. Observer, which medium not mentioned, we can imagine observer is from the air. He is observing
Yes, sir.
from the top view. That means he is observing in the air. So what is the refractive index of air medium? What is the refractive index of air?
Sir,
1. Refractive index of air
one.
is how
Yes, yes,
much?
sir.
1.
One, sir.
Yeah, now we can see this thing here. We need to find out this as a apparent depth we'll find. This is apparent depth, which will be equal to. So what is the formula? You recollect it now? What is the apparent depth formula? That
Yes, sir.
is a
Go
refractive
observer into.
index of observer medium into what? Tell me now. Real depth by refractive index of object medium.
Yes, sir.
Now you can see now first. Here refractive index of observer medium is how much? Where is observer?
Sir, the observer is in like air medium, sir.
Air medium. How much the refractive index?
1, sir.
1. So that is 1 into. Next. Now here the coin is here. First we'll move from here to here. How much
Yes, sir.
this distance from here to here?
6 centimeters.
Yeah, so 6 centimeters. And the refractive index of this medium.
8/5, sir.
This one, yeah.
Okay, 3/2, 3/2. Yes, sir.
Yeah, so that is what I will 3 by 2. Next,
Yes,
this
sir.
distance completed. Next, now coin is here. Now we need to move from here to here again. How
Yes,
much the
sir.
distance?
6 centimeters.
Yeah, 6 centimeters. And the refractive index of this medium.
8/5, sir.
Yeah, so that is 8 by 5. Yeah, that's it. Simplify it. How much now?
One minute.
This value 3 twos now. So this
Yeah.
value will come to be a 4 plus this is 2 4 2 3 and which will be a 15 by 4. So this value 16 plus 15 by 4. How much
Yes,
this
sir.
value?
31/4, sir.
31 by 4. They are asking to find alpha. So how
Yes,
much
sir.
is alpha value? Tell me now. 31.
31.
Okay.
Okay, sir.
Next. Tell me this one.
Sir, one small doubt, sir.
Mm.
Sir, like when we're pointing like light source from inside of water, sir, suppose like, and
Mm.
at certain angle it will become like completely along the surface of water, no, sir.
Mm.
And after that, like in
Good.
total internal reflection will take place, no, sir.
Mm.
So like this will happen from denser to rarer medium, no, sir.
Yeah, when the
So
light
like
travels from denser to rare only will happen.
yes, sir. Like what if like from rarer to denser if we throw like light,
I will tell you
then
that
we'll have
one. So complete this one. Next, I will do that one.
yes, sir.
Mm.
Like will that be like possible? I have that. I have
No,
doubts.
not possible. You will get to know.
Okay.
Mm. Mm. And then, so
Yes,
in
sir.
this case, what they're saying here, a vessel having a depth D.
Yes, sir.
Now, what they did now here, they filled with a some. So this one, this is D by 2 and this is D by 2. And this
Yes, sir.
refractive index is N1, this refractive index is N2.
Yes, sir.
Apparent depth of the vessel when viewed from the above. Hmm. So here, from here, this person is observing.
Yes, sir.
When we are observing from the top view, what will be the apparent depth they are saying? So this apparent depth dA, which will be given as. So tell me now. So this observable medium refractive index is 1 na?
Yes, sir. One,
Here
sir.
this is not mentioned. Take it as a air only. So this
Yes, sir.
is 1 into what? Tell me now here. How much this distance?
D by 2, sir.
Yeah, so d by 2 by refractive index of that medium now, that is n1.
N1, sir.
Next this one. This distance is d by 2.
D
Refractive
by 2,
index is how much?
N,
N2.
N2, sir.
So simplify it. So we
Yes, sir.
can take out the d by 2 is common outside. That is
Yes, sir.
1 by n1 plus 1 by n2. So that is how much will come, you can see now here, d by 2 into LCM. So
Yes,
we
sir.
have this is n1 plus n2 by n1
N1, N2, sir.
into n2. Yeah, that's it.
Yes, sir.
Okay.
Okay, sir.
Next one, critical angle.
Yes, sir.
Let us consider this is a junction for the two mediums, and this is the normal, and this is called as a normal. This is normal, and here this is a boundary for the two mediums. Okay, now you
Yes, sir.
can see now here. So let us say this is a medium one. Let us say this is the second medium. I'm calling this medium is a denser medium, and this we're calling it as a rarer medium. Now you tell me now what will happen. Light is moving from the denser medium to rarer medium. Let us consider.
Yes, sir.
Now, so what happens to the light ray now here? When it is moving from denser to rarer, what happens? It is incident now here, right? So this angle is, this is I. Now tell me what happens. Light is moving from denser to rarer. What happens to the light ray? It will move which direction now? Towards the normal, away from normal.
Sir, it will move away from the normal.
Away from the normal. So this is the I we have did. So that's why in this case the light ray which will move away from the normal, right? So it can
Yes,
be
sir.
moves like this, let us say.
Yes, sir.
Okay. Now this is I.
Okay, sir.
Now let us say here we have taken the one more light ray we have taken. Now here this so I'm slowly, this is my angle of refraction, this is my R. Now I'm increasing the angle of incidence. I'm increasing this angle now. Let us consider.
Yes, sir.
Now this light ray, one more light ray which is falling here. Then see what happens now here. So if I increase this angle of incidence, this I value will further increase. Then if I value increase, R value also increase.
Yes, sir.
Okay, that means what happened? Light ray. the light ray will move like this. Now this is R.
Yes, sir.
Now if I made the further, if I increase now, if
Yes,
I
sir.
increase now further, so then what happens to the light ray now here, which is incidenting the light ray incidenting here. If I further increase now here, angle of incidence we increase further. Okay, now if I increase further, then what happens now? If this angle of incidence, if it is equal to critical angle, then the light ray so will be lies only on the surface only like this.
Yes, sir.
And in this case, angle of refraction, in this case, angle of refraction, which will becomes how much now? 90 degrees.
Yes, sir.
Okay.
Okay, sir.
If the angle of incidence equal to critical angle, where the light ray will lies now here, it does not move to the rarer, denser, it will be lies only on the surface only will lies.
Yes, sir.
Okay. And if you further increase my angle of incidence, let us say, we are further increase the angle of incidence, then see what will happens now here. If we are further increase now, still increase angle of incidence, then what happens now? Then this is the light ray, it is completely reflected back to the initial medium only. It does not go to the another medium. This is the I here. In this case, this I is greater than theta c.
Yes, sir.
You need to understand here. So when this I is equal to theta c, where is a light ray lies now? Just lies on the surface only. If it is I
Yes, sir.
is greater than theta c, it will reflect it back to the initial denser medium only will reflect.
Yes, sir.
Now in this case, now you just see this thing here. So why it is happening? You see this thing here. The light ray moving from where to where? Denser to rarer. Denser to rarer. When the light ray moves from denser to rare, which direction the light ray will bend?
Sir, it will bend. Sir, denser to rarer it will move away from the normal.
It is moving away from now. If you have considered the light moving from rare to denser, now you see this
Okay.
thing, which direction the light ray will bend?
Towards normal. Towards
If it
normal.
will move towards normal will move na. So is there any
Yes.
chance to become the light ray will be reflected back?
No, sir.
Understood?
Yes, sir. Yes, sir.
So here this phenomena only because of the bending phenomena it will be TIR will happens.
Yes, sir.
See, when the light ray moves from denser to rarer only, we have a total internal reflection takes place. In any another case, TIR not happens.
Yes, sir. So like from rarer to denser, if it moves, like can the like rightly, like can it be on the surface, sir? Like here 90 degrees case,
No,
like
it
movement of
even cannot be on the surface also. So here, if the light ray, let us say here, in this case, if we consider, let us say the light ray.
yes, sir.
So here, this is just consider this is my rarer medium and this is denser medium.
Yes, sir.
Now tell me now when the light ray moving from rarer to denser. Now tell me what will happen. Which direction the light ray
Like
will
it will
bend?
move towards the normal.
It will move towards a normal. So that means it will move like this now,
Yes, sir.
isn't it?
Yes, sir.
Now tell me now here in this case, if this is the I value and this is what you tell me now R na,
Yes, sir.
Okay, now if we increase this one, so you never get this light ray will be lies to the on the surface.
Yes, sir.
Okay.
Yes, sir. So like, can it like align with the normal?
It can align with the normal. Yes, possible.
Yes, sir. Yes, sir.
But it cannot be the lies on the surface. Cannot be complete lies on the surface.
Yes, sir.
Okay.
Okay, sir.
Hmm.
Yes, sir.
Yes. Done.
Done, sir.
Hmm. Now, so this mechanism, so what we'll call it is if the angle of incidence is greater than the critical angle, then the light ray, what happens now? Send back to the same medium. This phenomenon is called as a TIR.
Yes, sir.
When we have a TIR, to have a TIR, the conditions are light should travel from way to way, denser, medium to rarer. This is the one first condition. And the second condition is what? Tell me now. Angle of incidence is greater than the critical angle. So this is I is the angle of incidence that must be greater than critical angle. What is the critical angle formula? That is given as sine inverse of what you tell me now? Mu r by mu d. Mu r means refractive index of rarer medium. Mu d means refractive index of denser medium.
Yes, sir.
Okay.
Okay, sir.
And what is the condition to have the TIR applications we have it? So it is works optical fibers will works based upon this only.
Yes,
And
sir.
mirage will be formed
Yes, sir.
and the loomings and sparkling of diamond. All these things are because of the TIR phenomena only.
Yes, sir.
Okay.
Okay, sir.
Next,
Sir,
circle of illumination.
sir,
Hmm.
sir, like this mirage effect once can repeat.
Mirage means this is one IP question, so we'll study this thing in detailed manner later. So mirage means what happens, you see this thing. So in the cold countries, in the hot countries, desert, this phenomena we can see. So
Yes, sir.
because of the light ray as we move the down. So here in the hot summer days, what happens? Yes, now temperature when you goes on move down, temperature will decrease. Temperature is high now at the near to the earth. Temperature is very high.
Yes, sir.
If the temperature is high, the near to earth it will behave like a rarer medium, and the above surface will behave like a denser medium.
Yes, sir.
When the light rays coming from the denser to rarer, it will be undergoes TIR and will be reflected back to the same medium.
Yes, sir.
And the person who is observing, so it will the light will coming from somewhere behind, somewhere from the bottom he will consider. So what we can say now, he will form an inverted image, he will consider the person. So
Yes, sir.
generally this phenomenon is called as a marriage. Okay, so like this we have a, so actual object is here, object is We have the object is there, some object is there, some tall object will consider.
Yes, sir.
Let us say some tall building or some sort tall tree will consider here. We have some tall object is there. Now this is on the ground. Actually, this is the ground. Now here a person who is observing from here, the light ray he is observing the top, this one he is observing. The light ray has to travel. This light ray will travel like this, and when it is reaches now, it will goes. What tell me now? It will be goes under TIR. This light ray will be go back to the same medium.
Yes, sir.
At this location, light ray will go exhibit a TIR. Now the person who is observing, he will consider that. So this light ray which is coming somewhere behind, he will consider as like that. Then he will consider a inverted image. He will consider here. He will consider there is some image is there, exactly this image. He will consider one inverted image.
Yes,
Okay.
sir.
And so actually this is the actual image, and the person he will feel that here is a image is there. This is an
Yes,
inverted
sir.
image, and this is the actual object here. And this
Yes, sir.
phenomenon is called as a mirage. Yes. And during
Yes,
the
sir. Yes.
IPE section, so we'll discuss in detailed manner. We'll do. Don't worry.
Okay, sir.
Hmm. Done.
Done, sir.
Okay, fine. So we'll continue tomorrow. We'll continue.